hard problem today. We have some heights restrictions. So this height is a maximum that can be, and we only allowed to grow at most one for each height. So we can't grow bigger than one, and they ask us to find the maximum height that we could reach. So it is a hard problem. It has 10 to the power of 5 restrictions, and the distances between this can be up to 10 to the power of 9. So it can be brute forced, can't be. That means we have to first we can sort these restrictions as we should. Second, we always start with 0. Start with 0, and that means we can check what possible allowed height we could reach. So if given restrictions is too high, we can check that what actual height could be. So this is forward pass. Forward pass adjust restrictions. So we have, for example, the previous height, maximum height we could reach, and it was starting from 0, and then we just checking. So, and given that we have some restriction, we start with this restriction, and if we have restriction that is bigger that we could reach by doing +1, we adjusting this value to be lower. Adjust. Okay, we do this in a forward pass. We have to repeat it for the backward pass. So after we do this repetition, we adjust it again, once again. So because we could have these situations where the right is lower than the left, and we adjusting this one to be lower. So after we have adjusted, we have actual intervals. So this would be 0, then some restrictions, height, and then again height. So if we have like left and right, we could have this grow. So this grows up, this grows up. They met at some point in the middle, and then we have to do some geometry. So we want this h big, and this is 45 degrees. It is also 45 degrees because they all +1. So this is 45 degrees, and we know this distance is known. This is from one restrictions to the other. So if we have this, we should solve it in a geometry way. So if this is so this one is left plus this some x, left plus x, and this one is right plus, and this is d minus x, d minus x. So the h equals left plus x, r plus d minus x. Then we have solving this equation gives us x value, r plus d minus l divided by 2, and then we go and put it back into h. Then we have h equal left plus this one, or we can say that we have this situation and we just doing this plus, so it's r plus d plus l divided by 2. So this is h. Then we have to just walk this after we do this backwards forwards path, we do analyze each one of the intervals individually. It doesn't matter what its order after we adjusted them, and we do this for each interval. So the main hardness of this problem is, first you have to know that you can adjust and you should adjust. So the hardness of the problem, so you have to adjust, you can and should adjust the restrictions heights. And the second hardness is that the math geometry, you have to introduce x, and this is situation where you have to either be very fluent or you have to draw it. So basically you're inventing this x, and this x is this because 45 degrees gives you the equal lengths of these triangles. Let's look at the code. And by the way, this is what Gemini draw for me. So we have left and right. This is how it looks like. You increase the left and the height peak moves to closer to the left. Same for the right. This is always 90 degree. You can check distances. You can make it almost like this. It's interesting that sometimes you see the height is not adjusted. But this situation would be impossible if we adjust them. So it's always the peak is less than restriction. Okay, now again let's look at the code. I didn't write it myself. I gave up after 56 minutes and just copy pasted it. Let's look at what can be done with this code. Look at this. So introduce a second array with corner cases, and you actually can skip all the checks. Just append the last item again. It will be okay, because the distance will be 0 if we already have it. And then we do one extra optimization, just 2 loops. The forward pass is to adjust it forward, and the backward pass does simultaneously adjusting and calculating in one step. So we just sort, then forward pass, and then backward pass. Okay, the rest is the same, nothing special. By the way, I prefer this concat, and it looks much better than if you try to do pushing and inserting. But concatenation does copy. Okay, that's it for today.